Okay. My name's Peter Tkacik, and I'm a professor of mechanical engineering at the University of North Carolina at Charlotte. I am in the motorsports focus area, so I have lots of research related to motorsports. But from a personality standpoint, I'm an engineer and grew up as an engineer, and I've always been that. Even as a child, I was an engineer. So I've always been looking for ways to make things work. I've made a lot of things. You know, this is where as a kid, I would gather all my buddies together and we'd build a tree fort or a float to put out on the river, or build a foxhole, dig a foxhole. I had a train set that took up half my parents' basement. I'm from a family of 7 kids, so there was a lot of elbowing to get that space. But anyway, the point is, I like doing things, and to do things, I like to see how things work, and then I adapt them to the resources I have at hand. So, when I was a kid, if all I had was a shovel, then I built a foxhole. If all I had was a hammer and nails, we made a tree fort. It's whatever we have. I have a lot of research here and a lot of research tools which we can take advantage of. They're harder to use in a school environment, but we can use them for the seminars to get points across. I have, at school, we have 4 teams with race cars: a Legends car, a drag car, Formula SAE, which is like an Indy car, and a Baja, which is like a dune buggy. But there's a 5th car, and that's mine, and it's a NASCAR Car of Tomorrow, which is it was raced by Red Bull last year at Richmond. It's a real NASCAR, and I have fitted it out with 2 racing seats, and I've repainted it so it looks like UNC Charlotte, and we use it in my summer camp for high school kids, and I have a class in the fall for juniors in engineering called Motorsports Instrumentation. And one of the things we do is we instrument the car, and then we take it out and we drive it. Actually, this year we drove the Formula car, which is like a little Indy car. But anyway, I have that. I also have the nation's 5th largest water tunnel, which is like a wind tunnel, but it's full of water. And the reason you would do that is because when you have an object in the water tunnel, you can put hydrogen bubbles out in front of it, and you can see the flow patterns much better than you can in a wind tunnel. It's slower, and it's easier to visualize what's going on. Those also have a lot of expensive electronic stuff that goes with them, but we don't need to get into that. Another thing I have that I think we could use in this class is a high-speed video system, and I can take high-resolution color videos to 1,000 frames a second, and it is at lower resolution capable of running to 100,000 frames a second. Now, how does all this expensive stuff apply to school teachers? And the answer is, what I like to do is figure out the resources I have and what I can do with it. So here I'm blessed with a lot of expensive resources. That's kind of cool, but typically I don't, so I make do with the best I've got. So NASA's doing rocket research, and they've spent tens of millions of dollars studying rocket nozzles. 2 professors came to me and said they wanted to do something, and I suggested some ideas, and they thought it sounded great. So for tens of dollars, I made a Schlieren imaging system to look at the flow structure inside a rocket nozzle, and we're matching at a microscopic amount of money NASA's spending. We're doing the same kind of research here. So my goal is to figure out who the seminar applicants are. Are they kindergarten teachers that want to draw pictures of NASCAR race cars, or are they high school physics teachers that want to do the math and science of what's actually happening? And go with whatever the customer is in the direction that we need to. There are lots of things we can do. Matter of fact, this summer I have a summer camp for high school kids where we rent the racetrack and have EMS and take the NASCAR race car to it. And I'm going to invite everybody out to that because it's just kind of a cool thing to do. But the point I want to make is that if it's a high school group of physics majors, I have computational models that I've developed on the computer that can be put on any PC, and I wrote it myself, so it's not illegitimate software. I don't care if they copy it and send it all to China. It doesn't really matter to me. But it allows you to do calculations on things like the wedge adjustment and then how it affects the handling of a car. But if it's kindergarten teachers, then what we'll do is we'll do projects related to NASCAR, the science of NASCAR that takes popsicle sticks and glue to put together. So I'm willing to go in any direction. It doesn't really matter to me the direction we go, but I think we can make a really cool activity out of this. Let's see, what else? Yeah, so the core of the seminar is applied to using the resources we have here, learning about NASCAR, and teaching the science that goes along with racing and how it applies to this industry, with the idea, and this is what I do in my own classes, with the idea of taking this and engaging students and making them more excited about science and math. And so that's sort of where I'm coming from.